Okay, so all through chapter 5, we're going to be dealing with normal distributions. So the first thing we want to do here is just talk about what makes something a normal distribution. So we have some basic properties that we're going to run through here. The first of these is to note that when you talk about a normal distribution, you are always dealing with a continuous random variable. Now remember from chapter 4, discrete random variables are counts. Continuous random variables are measurements, things that fall on a continuous scale. So instead of looking at situations where we're counting the number of people or the number of cards, we're going to be measuring. So temperatures, heights, weights, lengths of time. All right. Other things to make sure that you keep in mind is the shape of the distribution and its defining values. All right. Now, the shape of the distribution, we've talked about this shape before back in chapter 2. If something is normally distributed, what that means is it follows a symmetric bell-shaped curve. Okay, so the shape of a normal distribution is always going to be this basic bell-shaped curve that you're seeing here. And each normal distribution is defined by its mean and its standard deviation. So when you look at any normal distribution, it's going to be defined with continuous values of x. It's going to be centered at its mean. All right, that mean mu will always mark the center. And the standard deviation, all right, we know sigma represents our standard deviation. The standard deviation is what determines how wide or how narrow that curve is going to be. So you can have normal distributions that are very tight and narrow like this. You can have normal distributions that are very wide and spread out like this. And the differences between those is based on the standard deviation. The wider the curve, the larger the standard deviation because the values are more spread out. All right, now some other things to keep in mind when you're dealing with a normal distribution. The total area under the curve is always equal to 1. Now, when we talk about the total area, what this means is if I were to come in here and look at, take that down a little bit, and look at all of this area underneath the curve. So I'm staying below that line, staying above the horizontal axis. All right, if I were to shade in all of this region underneath the curve, the total area of that shaded region is going to be equal to 1 for every normal curve, no matter how narrow or how spread out the values are. And then lastly, the normal curve will never cross the x-axis. All right, it gets very close and you can see it trails off on either end, but it never crosses the x-axis. All right, those are things that have to be true. These properties have to be true in order to have a normal distribution. All right, now, like I said, we're going to be working with normal distributions all the way through chapter 5, but we're going to start with the most basic one in section 5.1. All right, so we're going to be focusing in on one particular normal curve, and this is called the standard normal distribution. Now, like I said, every normal curve is defined by its mean and its standard deviation. So when you're dealing with the standard normal distribution, your mean is always 0, your standard deviation is always 1. And because the standard normal distribution is one that we look at very specifically, we even have a different variable that we use. So x is kind of our general random variable. If you see that things are defined in terms of z, then you know that you're now dealing with a standard normal variable. And again, what it means to be standard is the mean is 0 and the standard deviation is equal to 1. All right, so the standard normal curve is what you're seeing here, 0 at the center. And remember, values go out about 3 standard deviations below the mean and about 3 standard deviations above. Now, what we're going to be trying to do is figure out the area under the curve for different regions. So we know the total area is equal to 1. We want to be able to focus in on a particular area and determine the area of just that one region. And what we're going to use to do this is something called the standard normal table. So the calculations for finding the area under the curve, those are beyond what we have right now. It requires some calculus. So those values have been summarized for us and placed in this standard normal distribution table. This is one of the other things that I had linked for you on the section 5.1 page. All right, so let's look at our first example to give ourselves an idea of how we're going to use this standard normal table. All right, so a couple of things to note here. Number one, we're asked for area, so we know we're going to be using that standard normal table, and we're asked to look at a value of z. Now again, when you see that something is defined in terms of z, you know its mean is 0 and its standard deviation is 1. So what I'm going to do first here is I'm just going to go ahead and sketch out the standard normal curve. It's centered at 0. It goes 3 standard deviations above and 3 standard deviations below the mean. All right, and again, this is the standard normal, so things are defined in terms of z. And then what I'm going to do is shade in what I'm being asked to find. Okay, so this wants me to look at a z-score of negative 2.19. So if I wanted to approximate that, right, I could come down here, it would be a little bit past negative 2. All right, I'm just approximating here, and I could section off the curve at that point. And then what I'm being asked to find here is a cumulative area. Now, area is always directional. It's going to be left, right, or between. So when you hear that term cumulative area, this is just another word for the area from the left because it's everything up to that value. So what this problem is asking me to find is the area under the curve of this little small region right here to the left of negative 2.19. And I'm going to use my standard normal table to find that. All right, now I showed you the whole table. I've just got a little clip of it here, but you can refer to your table. It's the same information. And what I'm going to do is look up the z-score using the outer edges of the table. Now my z-score is negative 2.19. This table puts z-scores in the left-hand column and across the top. So the way that we're going to look this up is in the left-hand column, we're going to look for the z-score, but only to 1 decimal place. We're not rounding, we're just kind of cutting it off. So to 1 decimal place, my z-score is negative 2.1. And then the second decimal place, for us the 9, is what I'm going to look for across the top. All right, so it's a two-step process that you have to use to look this up. And then where those two things intersect, right, the row and the column, the standard normal table is going to give you the area always to the left of your z-score. And because that's what we wanted here, we don't have anything else to do. Right? Once I look up my z-score in the table, as long as I look it up correctly, the value that I see in the table, 0.0143, is the area to the left of that z-score, and that's exactly what I was asked to find. All right, so let's try this again just to make sure we understand how to look up these z-scores. All right, the next one here, again, it's a cumulative area, so we're still talking about an area to the left. We're still dealing in terms of z, so you'll notice how I sketched out my scale, centered at 0, standard deviation of 1. And this time, I'm asked to look at a z-score of 2.17. So now we're positive, all right? We're up here on the upper end of the curve. Again, I'm just approximating 2.17 would be somewhere up here just past 2. And then be careful with direction, right? Don't always assume that it's going to be a small area or that's going to be in the tail. The direction of the area is given. In this case, it was cumulative. That means we want an area to the left. So I'm going to be looking for a larger area here, all right, which would be this entire region to the left of that z-score 2.17. Now, we know the total area is 1, so the areas are always going to stay between 0 and 1. But where the previous problem had a small area, 0.0143, this one's going to have a larger area, something much closer to 1, because 1 is the total area under the curve. So we kind of know what to expect when we go to our table. All right, so again, I'm going to look at my z-score on the outer edges, 2.17. Make sure you're on the positive page. There's a negative page and a positive page. All right, but then look it up to 1 decimal place here, 2.1. Second decimal place is here across the top. That's my 7. And where those two things intersect, again, the standard normal table is giving me the area to the left of my z-score. All right, and again, that's exactly what I was being asked for here. The cumulative area is the area of this entire region that we shaded to the left, and that's exactly what we find in our table, right, which is, again, should be closer to 1. It is. We have an area here of 0.9850. All right, so you might want to take a minute here, pause the video, go into your practice, and just work through a few of the problems that ask you to find a cumulative area or an area to the left, just to make sure that you're correctly understanding how to use that table. All right, and then once you feel comfortable with that, then what you want to be able to do is expand on this, right? You want to be able to talk about 3 different possible areas. All right, area to the left, all right, looks at values less than. All right, and if that's what you want, then all you have to do is look it up and take the area directly from the table. But sometimes we want to be able to do a different direction. All right, so if we want to look at values that are more than, this would be an area to the right, a greater than. And in that case, we have to flip the area in the table, meaning we're going to subtract it from 1. All right, so let's do a quick example of that, and then we'll look at that third case. All right, notice the difference here. I'm still asked for an area, but I'm asked for the area in a different direction. So I sketched out my standard normal curve. I'm going to approximate my z-score, negative 2.16. I'm going to section off the curve there, and then I'm going to make sure that my direction, in this case, is to the right. So this time, the area that I'm finding is this entire region to the right of negative 2.16. All right, now, I'm going to take my z-score to my table, just like I did for the other cases. I'm going to look it up to 1 decimal place first. That'd be negative 2.1. Second decimal place across the top would be a 6. And where those two things intersect, here's where you want to be careful. The table always gives me the area to the left. In this case, that would be 0.0154. Now, if that's what I was asked to find, that would be my answer, but that's not what I was asked to find here. I was asked to look for the area to the right. So what I'm going to have to do to flip that area is subtract it from 1, and then I'll have the area to the right, which makes much more sense. It should be a larger area here of 0.9846. Okay, so to the right, greater than, only difference is you have to subtract from 1. All right, and then third case is if we want an area in between, we're going to look up each z-score, get its corresponding area, and just take the difference, the larger area minus the smaller area, to get the area in between. All right, so one more example here. We've got our standard normal curve. We want an area, but this time in between. So I'm going to estimate, I got 2 z-scores here. I've got a negative 2.16 and I've got a negative 1.35, right? Approximating each one. But this time, all I want is the area of this region in between those two z-scores. So I'm going to have to look up each one individually. I've got my negative 2.16 and my negative 1.35. So looking up negative 1.35, I'm going to go 1 decimal place here, negative 1.3. Second decimal place across the top is the 5. And remember, where those two things intersect, your table always gives you the area to the left of that value. Now I'm going to do the same thing for the other z-score. I actually looked that one up over here. Negative 2.16 had an area to the left of 0.0154. Okay, so notice I just looked up each one in the table. I didn't subtract from one. I just pulled the area exactly as it was given. And then what I'm going to do to convert this to an area between is I'm going to take the larger area, 0.0885, and I'm going to subtract the smaller area at 0.0154. That's going to give me the area between, which is what I was asked to find here, at 0.0731. Okay, so the first thing you're going to be doing in Chapter 5 is just understanding how to use this table to find area left, area right, and area in between. All right, once you have a good understanding of that, and once you've gone through a good many of the practice problems, you also want to make sure that you understand that finding the area under the curve is the same thing as finding a probability. And sometimes the questions are going to switch the wording and ask you for probability instead. And that's where you want to keep these three cases in mind. All right, you want to remember that when you find the area to the left, that is the same thing as the probability less than. When you find the area to the right, that is the same thing as the probability greater than. And when you find the area between, it's the same thing as the probability of being in between. Okay, so just to show you what this is going to look like, I've pulled up one of the problems from your 5.1 practice. All right, this is number 23. And the question here, notice how it's worded. It says, find the indicated probability using the standard normal distribution. All right, so what I'm going to do is I'm going to say, okay, it gives me a z-score. All right, I know a z-score means I can use my standard normal table. So I'm going to click here and I'm going to pull up the negative side of the standard normal table. Now my z-score given is negative 2.13. All right, so if I look up negative 2.13, right, negative 2.1 on the left-hand side, underneath 0.03 across the top, I'm looking at an area of 0.0166. Now what I have to remember is the table gives me area left. So that would be the probability less than negative 2.13. If I want to switch that to probability greater than negative 2.13, then I now need an area to the right, and I'm going to have to subtract that 0.0166 from 1. All right, and that's exactly what you're going to see here. If I were to go into the question help, right, you use the table to get the area, and then you have to remember that that is an area left. If that's what you want, you are finished. But if it's not, if you want an area right or you want to go greater than, you have to take what's in the table and subtract from 1. All right, so the best thing to remember when you're working through the homework here, area to the left is the same thing as the probability less than. Left less than. Area to the right is the same thing as the probability greater than. And between is between, right? There's no real different way of stating that. If you're asked for the probability that a z-score is in between two values, then you do just what we did here for finding the area in between, and the probability is the exact same thing as the corresponding area. Okay, so what I want you to do here is take some time to really go through the homework in section 5.1. There's lots of good examples of making sure that you understand how to correctly find the area under the standard normal curve. And then once you have a good understanding of that, you're going to come back, you're going to watch the second video for 5.2, which will finish out these notes, and you're going to learn how to apply these methods to other normal distributions with any mean and any standard deviation.